Hello YouTube, welcome back. Here we are at 2017 BC2. This will be our 84 TI84C screencast. Then we'll have a TI-inspired CX cast screencast. Then we'll have a Sage worksheet from CoCalc or Sage Math Cloud. And then we'll have a Pythonic solution, 4 new screencasts just on this one question BC2. Using a Jupyter notebook, also on cocalc.com or cloud.sagemath.com, otherwise known as SMC Sage Math Cloud. Okay, so the figure above shows the polar curves of r equals f of theta equals 1 plus sine theta is that smaller region. 1 plus sine theta cosine 2 theta. And r is g of theta, which is 2 cosine theta, which is that larger region marked, well, which encompasses S and R, okay? S is the area in between, I suppose. For 0 through pi radians inclusive for theta, let R be the region of the first quadrant bounded by the first curve R equals f of theta and the x-axis. Let S be the region in the first quadrant bounded by the curve R of equals f of theta and the curve R equals g of theta and the x-axis. Find the region, the area of the region R. Okay, so let's see how we're going to set that up. Well, on the exam, all you have to do is write what you're going to do in the calculator, but you don't have to write any calculator reads. You know, just write the math. 2017 BC2, question 2a. We need 1/2 the integral from theta 1 to theta 2 in radians, of course, of f of theta squared, whatever f of theta is. It's 1 plus sine theta cosine 2 theta, but we don't have to worry about that until we plug it into the calculator. So I'm just going to write this. Squared d theta, and I got, last time I did this, 0.648. So the idea here is to show the tech behind the TI84. So let's do that. Whoopsie, what happened? There it is. All right, so let's go into y equals, and you don't want y equals, you want polar mode, right? Well, do we even have to graph it? Nah, we don't have to graph it. They give us the graph, so we don't have to graph it. All right, so let's just do what we said. It's going to be 1/2. How about 0.5 times the integral? How about a math 9 from 0 to pi over 2? You could write pi divided by 2 or alpha y equals 1 and put the control caret for pi there over 2 there, just to make it look nice. Of the function, which was 1 plus sine theta times cosine 2 theta quantity squared. So 1 plus sine theta. Now, I could use theta here, I suppose. I'm not in polar mode, so, you know what, I'm just going to use x. If I was in polar mode, it would say theta. Okay, whoops. Close parentheses, times, then I don't think I need to say times, so it's an implicit multiply. Cosine of 2x, and that, with respect to x, don't forget we're squaring that whole thing. Right here. It's not going to let me do that. All right, I'm going to need another set of parentheses. Second insert open. Second insert close. And squared. All right, so now we're squaring the quantity and all of that with respect to x, and let's see. And we got 0.648, which is what we expected. Good. Perfection. All right, let's go back to the question. 2b, array theta equals k, where k is between 0 and 2 pi, pi over 2, non-inclusive, divides the region S into 2 regions of equal area. Write, but do not solve an equation involving one or more integrals whose solution gives the value of k. All right, so what we want to know is, let's see, oh boy, let's see, can I get an ink layer out of this? Give me an ink layer, go, yes. All right, so they want an array, which is theta equals a constant, so say theta is, I don't know, pi over 4 radians, let's say that's what that is. So if theta equals k, and k is pi over 4 radians, let's say, roughly, or maybe it's pi over 3 radians, whatever it is. Is that the solution? Is that what's going to make this region, that area, equal to this area over here? That's what they want. So it's when we want, it's when the area from 0 to k bounded by the two curves equals the area from k to pi over 2. Okay, and this would be 0 radians, and this would be the pi over 2 radians, right? All right, so let's write that. Now they said to write it, but you don't have to solve it. So let's do so. All right, so 2b, you're not actually going to do any calculating on here. You're going to say, when is the polar area from 0 to k bounded between the two curves? So how about g squared of theta minus f squared of theta, quantity d theta, equal to the area from k to pi over 2 of the same expression. So if you wanted to actually solve this, you'd have to integrate, you have to plug in the k and the 0, you'd have to plug in the k to the pi over 2, then you'd end up with some kind of an equation for k, and you got to get k alone algebraically. But they didn't ask you to solve it, so you're done. Alrighty, let's go back to part C. Part C says, for each theta between 0 and pi over 2 inclusively, just a moment, I need my mouse. Here we go. Let w of theta be the distance between the 2 points with polar coordinates theta, f of theta, comma theta, and g of theta minus comma theta. Write an expression for w of theta, and find w of a, the average value of w of theta over the interval from 0 to theta over pi over theta between 0 and pi over 2 radians. Well, the distance between those 2 points is just g of theta minus f of theta, because those are radial values, right? There's r equals g of theta and r equals f of theta, so the difference is the difference along the radii. So I think what we're going to say is, and then we got to solve it, right? So let's see if we can fit 2c down here. All right, 2c. Let w of theta be g of theta, which is bigger, minus f of theta. So those two radial distances, that is the distance in between. What is the average of this function? It's going to be 1 over b minus a, the integral from a to b of the function. And when I plugged this into the calculator last time, I got about 0.485. So let's do that. All right, so how are we going to punch this up? Well, this is a math 9, and g of theta and f of theta, I guess we should have put them, I guess we could have graphed this and have this in R1, R2, I guess, but whatever. I guess we'll just type it out. That quantity, that area, divided by pi over 2 means times 2 over pi, right? So I'm going to write 2 over pi times that integral. Let's see. So let's get to the calculator. Where's my calculator? All right, so I'm going to write alpha y equals for a rational. Instead of dividing 1 by pi over 2, I'm going to just multiply with the reciprocal, which is 2 over pi. Do a math 9. From 0 to pi over 2. Of the quantity. Now I need g minus f. G is 2 cosine theta. And again, I'm going to be using x here. Minus the quantity of f, which was 1 plus sine of theta, cosine of 2 theta. We're in radian mode and everything, so we're happy. And we got to close up parentheses because we're subtracting all of that. And again, x for theta and dx for d theta. And I think, is that it? Let's see. And we get 0.485. We do. That's it. Perfect. Alrighty, now let's go back to the question. What's part D? Using the information from part C, find the value of theta for which W of theta is that average value, the 0.485-ish, and is the function omega W theta increasing or decreasing at that value of theta? Give a reason. All right, so, well, if W is G minus F, W prime is G prime minus F prime, we got to figure out when G minus F or W equals a 0.485. Well, we could do this in function mode. All right, so I'm going to go back into the calculator. And Y equals. And I'm going to make Y1 equal to F, just so I know which is which. So it's going to be 1 plus, I should have done this at the beginning, so I just have to write Y1 and Y2 everywhere, but what have you? Sine of X, cosine of, 2X. Okay, good. And then G's, let's make Y2 the G of theta, which is 2 cosine theta. And again, I'm using X instead. And I don't know, how about a zoom trig? And we're only really interested from 0 to pi over 2, where they intersect, from 0 to pi over 2. And that's 0 to pi over 2 right there. That's pi, that's 3 pi over 2, that's 2 pi. I think each tick mark is pi over 2, right? So, intersects there, huh? So, wait, all right, let me trace this thing. Trace. Okay, so where is pi over 2? Well, look at my window. I'm going from negative 8.63 to positive 8.63 radians, and my x scale is pi over 2. That is pi over 2. So do they intersect somewhere before pi over 2? Did I input this right? Wait, let me look at my equals. 1 plus sine of x cosine of 2x and 2 cosine of x. Yeah, that's it. Okay. Let's make this more obvious, okay? Let's see. If the range is 0 to 2 at most, and the domain is 0 to pi over 2. All right, let's blow this up a little bit. It's not going to be a square window, but that's okay. From 0 to pi over 2, just see what's going on. Whoopsie, what did I do? How did I do? 0 to pi over 2. There you go. And how about, just for fun, I like to do pi over 24. And 0 to 2. There you go. So there's F. And here's G. They're intersecting of what? They're intersecting there? What did I get last time? I think I got 0.518 last time. Let's retrace this a little bit. Okay. So each tick mark is pi over 24. So 1 pi over 24, 2 pi over 24, which is pi over 12, 3 pi over 24, which is pi over 8, 4 pi over 24, which is pi over 6, 5 pi over 24, 6 pi over 24, which is pi over 4, right in the middle. 1, 2, 3, 4, 5, 6, 7 pi over 24, 8 pi over 24, which is 3 pi over 8 pi over 24 is pi over 3, or 60 degrees, pi over 3 radians. Then 9 pi over 12, 9 pi over 12 is 3 pi over 4, 9 pi over 12, 3, wait, 9 pi over 12 is 3 pi over 4, yeah. No, it's 9 pi over 24 is 3 pi over 8. Okay, then 9 pi, then 10 pi over 12, which is 5 pi over 6, and 7 pi over 12, to 11 pi over 12, and then 11 pi over 12, 24, and then 12 pi over 24 is pi over 2, right, okay. Well, I'm in ready mode. This graph doesn't look right. Something screwed up here. trying to do? Oh, I misread the question. I'm sorry. I don't want to graph f of g, which is y1, and f of theta, which is y1, and g of theta, which is y2. Turn that off. I want to graph w, which is g minus f. In other words, y2. Ah, no wonder. No. y2 minus y1. That's what I want. That's what I want to graph. And that's when, and I want that to be equal to, I want to see when that is equal to this answer. So let's store that as y4. What happened? What happened? Why can't I do that? I can't store that in y4? All right, let's see, mode. Let's make it float. Let's get a whole bunch of decimals here. And let's do the previous question, previous calculation. And let's say 485446. How about that? Now let's go. So the domain here is 0 to pi over 2 radians, so 0 to 12 pi over 24 radians. And then we want to know when that intersects that purple line, and they intersect at about, well, let's find out. Second traces calc, intersect. First curve, second curve. There's only one intersection point, so I don't have to guess. And it's 0.7517-ish. Okay, 517-ish. All right, so this was 0.485446. Just jotting this down, and this is 0.51. What is it? 7. We're gonna write 0.518. But we're going to use 517.688. How about that? Get a little more accurate. Okay, and so now remember what the question was. Is W itself increasing or decreasing at this value that we just got? So we got to figure out W prime at this number. Alrighty. So now who's W? Let's go back to the calculator. W is y3. So I wanted the derivative of y3 at that 0.517688-ish. Okay, so second quit. Okay, math 8 with respect to x. I'm going to put y3 at about 0.517688. There you go. And we get negative 0.581-ish, and that's the correct answer. Good, we're done. We got it. And therefore, is it increasing or decreasing? They want to know, and it's decreasing. Alrighty. So let's write that down. Let's see. Oh, we're going to write this down. Okay, so I'm going to say 2D. When is W equal to that? I'm going to say when is W, which is G, when is W, which is equal to G of theta minus F of theta, equal to that, and I'm going to write out that we used 0.485446. Okay, and then what's W prime? Well, okay, wait, hang on. So that means that theta is about 0.518. Okay. But then I want W prime there. W prime at 0. And I'm going to use 517688 is approximately negative 0.581. Therefore, W is decreasing there. When W of theta equals W of A. Ta-da! That's it, done. Alrighty. That wasn't so bad. So I think we're done, you two. Hope that was helpful. Have a nice day. Bye-bye. TI84C version.